All right, hello class. So we're doing the homework, and this is 7.3, and I was requested to do number 11. So let's go ahead and dive in. And just remember for 7.3, the formulas that we will need will be, this is the central limit theorem to find the standard deviation of a sample mean is the standard deviation of population divided by the square root of the n, which is the sample size. And always remember that the mean of the sample mean is the same as the mean of the population. And we will need to know the z-score formula, and this is the z-score formula. So z is equal to x minus the mean divided by the standard deviation of the sample mean. So that formula, the z-score formula, and the formula for the standard deviation will be the two formulas we'll be using for this problem. Alright, so let's go ahead and dive into it. Let me bring up Excel. Alright, so it says, what is the probability that the sample mean commute distance is greater than 17 miles? Alright, so before we do anything, let's find the standard deviation, which is, alright, so the standard deviation of population is 10.1 divided by the square root of the sample size is 94. All right, so that's our standard deviation, 1.041. So what is the probability that the sample mean commutes distances greater than 17 miles? So the one for the probability, so let's find the z-score. All right, so the z-score of 17 miles. Okay, so equals of 17, so 17 minus our mean, which is 20, divided by our standard deviation. This is our standard deviation of the sample mean. Alright, so we're going to round this answer to 2 decimals because the z-score for our tables requires 2 decimals. So 2.88. Alright, so y'all should have the z-score table sheet. Alright, so I'm going to pull up a table online. Alright, so negative 2.88. So negative 2.88. Perfect. So, alright, so that's our area. And remember that the question said is greater than. So it will be 1 minus. So equal 1 minus 0.0020. Alright. Oop, not that. Bring up our. Okay, there you go. 0.998. Perfect. Is between 21 and 24. So it goes Z, the Z score of 24. I just like to do the greater number first. You can find Z score of 21 first or 24, it doesn't matter. Then we'll find area below. Then the Z score of 21. Alright, so we got 24 minus our mean, which is 20, divided by our standard deviation of the sample mean. Turn it to equal sign. Alright. Turn it to 2 decimals. You can usually just turn it to 2 decimals probably in your head. I just like doing that. Alright. 3.84. Alright. That's a pretty large actually for z-score. So 3.84 is almost 1. So anything above 3.44 is going to be considered a 0.99999. So our area, let's put 0.999. Alright, and then for 21 equals 21 minus 20 divided by standard deviation. So our z-score, alright, 0.96. So 0.96. 0.96, perfect. 0.8315. Alright, so to find the in between, we just subtract the areas. So the higher area minus the smaller area, and give us what's in between. So 0.1684. Find the 90th percentile of the sample mean. So when they went to find the 90th percentile, so that means they give us a percentile, but they went to find the x value. So for that, the formula we will need so this will be the formula to convert the z-score to raw score. So x is equal to the mean plus the z-score times the standard deviation. So this is the formula we're going to use. Alright, so first you have to convert that 90 percentile to z-score. So we look inside our table to find 0.9. So look like this is the closest to 0.9 because this is 3 under. That's 15 above 0.9. So this would be the closest. So this is 1.28. Alright, so 1.28 is the z-score. Okay, we'll put it over here. Alright. P90 is equals to alright, so remember we have 1.28. So it's gonna be 1.28 times our standard deviation plus the mean, which I believe was 20. Alright, so now we have our x value. It's 21.3334. Oh, this would be wrong. It said round to 2 decimal. Oh, usually if you round to more off, if you don't round to decimals, they say it'll be wrong, but they still gave it right. So technically it's supposed to be 21.33, but they still gave it right. So just be aware of that. So would it be unusual for the sample mean distance to be greater than 23? All right, so greater than 23. So z of 23, then the area. So we find our z-score. So we're gonna use the same z-score formula, which is 23 minus 20 divided by our standard deviation. All right, this to 2 decimals was should be 2.8. So the area for 2.88. So 2.88. All right. 0.9980. Would be unusual for sample mean distance to be greater than that. So we have to do this since it's greater than, it's the complement. So you gotta do 1 minus. So that would be unusual. And the reason it's unusual because it's less than 0.05. So if it's less than 5%, 5% into decimal form is 0.05. So it would be unusual. All right, for the last question, do you think it would be unusual for an individual to have a commute? So I want you to know this. The difference between these two questions are not the same. This one says will be used for the sample mean. This one says for the individual. When it says sample mean, we're going to use our standard deviation using the sample means. So we're going to use our new standard deviation for this one. But when it says for individual, we're going to use the standard deviation that they gave us, which was the standard deviation of the population. I can scroll it up. Uh, Let me scroll up. I'm trying to show y'all. Okay, there you go. Darn it. Sorry, guys. I press solution on accident. Oh my goodness. Okay. Oh, I gotta go try another. Press on accident. It's okay. We'll just skip down to our last question. Come on. Okay. So we're just gonna skip until we get to our last question that was at. Because we did all these already. So you wanna see all these? Just rewind the video to earlier. No. Uh, Sorry for pressing the guided solution. Whenever you press guided solution, I it will make you try another problem because the guided solution gives you the answer. So I'm just skipping all the way to wheels at part 5. So I'm just skipping all the way to part 5. Okay, and like I was saying, the difference is sample mean and individual. Whenever you see individual, you're going to use the standard deviation of the population. This one, the sample mean, we computed our new standard deviation. So this one we're going to use the standard deviation as given to us, which is the 7.2. So let's go ahead, put it back up Excel. So I'll do it over here. So the Z of, and let's see what they're asking for. Come on. So 28 miles. So Z of 28. So let's go and put in our Z square formula. Just 28 minus, alright. So the mean is 14. And the standard deviation is 7.2. And remember, we're using the population standard deviation because they're asking for the individual. If they was asking for the sample mean, we'll compute it. To compute the new standard deviation. All right, but we don't have to because they're asking for individual. Always remember individual. So, all right, so 1.94 on the table. 1.94. All right, so 0.9738. 0.9738. Come on. All right. And they're asking for the distance that's greater. So make sure to do the complement. So the complement of this equal 1 minus. All right, so that will be your answer. And you can see that this is less than 0.05. So 0.026262. 0.0262. And so this would be unusual because it's less than 0.05. All right. Boom, boom. All right, and that's correct. And that's how you do number 7. Excuse me, number 11 on chapter 7.3. All right, thank you guys. I hope that helped, and I'll see you soon.